If you didn't do the notes, do this second example with us, and then you can go out and do the rest of the notes. Okay. So this is what we have. And today, this is what we're going to be practicing. So we're finding different characteristics for the piecewise functions. I'm not going to ask you to find all the period that you're in. So fourth tray. Okay, are we ready? So I'm not going to ask you to do every single thing for each graph that we do. I'm going to pick out just a few things, but for the notes, we're going to do all of them, all right? So the first couple things that we're going to do is we're going to evaluate the function for specific values. So you just need to see which part of the function you can plug that value into. So if I look at -6, is that a number that is less than -3 or greater than -3? Less than. So -6 is smaller than -3, so we're going to plug it into this one. So -6 plus 4 squared. -6 plus 4 squared is, anybody? 4? Mm-hmm. Okay. This one says to plug in -3. So which one of these allows you to plug in -3 exactly? The bottom one, because this is the one that says equals -3. So the negative version of -3 minus 3, what is that? 0. Okay. Is 0 less than -3 or bigger than -3? Bigger. So we're going to plug that into the bottom one. -0 minus 3. -3. Is 10 smaller than -3 or bigger than -3? Bigger. So we're going to do negative version of 10 minus 3. -13. And all of these points should be visible on the graph. So the point -6, 4. -6, 4. -3, 0. Left 3, 0. There it is, right there. 0, -3. There's 0, -3. And if we had a bigger graph, we could look at 10, -13. But our graph isn't big enough. Yeah. Mm-hmm. All right. The next thing we need to look at is the domain. So for these graphs, it is possible that you could have something missing from the domain, or it's possible that they could be negative infinity to positive infinity like we're used to. So what we're going to do first is we're going to look at the left side of the picture, and we're going to look at the right side of the picture. And what do you notice when you look at the left side and the right side? What numbers from left to right? Negative infinity to positive infinity. So do not write this on your paper. Don't write anything yet. So my prediction is that I think that the domain is going to be negative infinity to positive infinity, but something weird happens to the graph in the middle. What x value does the weird thing happen at? -3. So I think the domain might be negative infinity to positive infinity, but I'm a little bit worried about the x value of -3. I want to make sure that that x value is not missing from the domain. So if I look, I just want to make sure that -3 is included. Right here, the x value of -3 is missing. Everyone see that it's missing? That's a hole in the graph, so that's missing. But here, the x value of -3 is getting used. So it turns out, even though there was a weird spot in the graph, I don't have to worry. -3 is still part of the graph. Now, that was the only part that I was worried about. So the graph is fine. The domain really is negative infinity to infinity. So I'm going to go ahead and write that. I was worried about negative 3, but it turns out I had no reason to worry. Okay. I'm going to do the same thing for the range. I'm going to look from the bottom of the graph to the top of the graph, and then I'm going to see if there's any y values that I need to worry about. So the bottom of the graph is down here. The top of the graph is up there. So what numbers do you see so far from the bottom to the top? What's the number for the bottom? For the bottom? Negative infinity, because that's an arrow going down. What about the number for the top? Positive infinity. Okay. What are some y values that we might be worried about? What are some y values that look a little weird? Positive what? Positive 1. I'm worried about positive 1 because there's a hole right here. And then do you guys see any other y values that are a little bit weird? So this whole portion of the graph is kind of strange, right? We're not used to seeing that happen. So I'm just a little bit worried about anything from like 0 to 1 just because this is where all the weird stuff is happening. So I can see right here, this is a y value of 0. There's a y value of 0 here as well. So I don't have to worry about 0. 0 is definitely included on the graph. All the numbers between 0 and 1, those are included over here. They're also included over here, so I don't have to worry about those. And then here, this is a y value of 1 that is missing. But if I look over here, there's a y value of 1 that is actually there. It's included. So y value of 1 is something I was interested in. I wanted to check it out, but it turns out it's not missing from the graph at all. So the range of this graph is also negative infinity to infinity. I had to stop and think about it before I just wrote the answer, but that value is not missing from the graph. It's there. Okay, how do we feel about those two answers? Can we see why we needed to stop and think? And can we see why they actually were all good? Yeah? Okay. Increasing intervals, decreasing intervals. What do I draw on my graph to find those? Need my stick figure. And do I use x coordinates or y coordinates? I use x coordinates. So my stick figure is going to start right here. And what x value do I have? What's the x value of a left arrow? Negative infinity. And if my stick figure starts walking, is he walking downhill or uphill? He's walking downhill. He decreases all the way until he gets right here. What x value? What x value do you guys see right here? -4. So -4 is the value. I'll just make it a little bit bigger so I know that's not just a marking on the graph, but that's truly the number I'm using. So stick figure gets down to -4, and then once he gets past -4, what is he doing for just a little bit? He's increasing for just a little bit. And then there's this hole. He trips, he falls into the hole, and at the bottom of the hole, there's a bunch of sludge, and he gets stuck in there and he dies. It's very sad. I know, it's weird. It's sad, right? It's sad. Okay, so that stick figure is gone. What number did the stick figure fall into the sludge and die at? What x value? -3. Okay, so the stick figure had his sludgy death at -3, and it was actually a sewer, so he died in like poopy sludge. Isn't that sad? Let's have a moment of silence for him. Okay, we're done. All right, now a new stick figure started over here, and this stick figure started right at this dot right here. And what number is that dot? X value. -3. So this stick figure is starting at -3. And what direction is this stick figure walking? Downhill. So this stick figure is decreasing. And decreases all the way to this arrow, which is what number? Infinity. Okay. So let's write the answer for increasing real quick. We have the word increasing in between this number right here and this number right here. So how should I write that answer? Increasing is -4, -3. Okay? -4, -3. And then when the stick figure was standing right here, was he actively walking uphill? No. When the stick figure fell into the hole, was he actively walking uphill? No, yeah, he was falling into a hole and dying. A hole technically doesn't exist on the graph, so you can never include a hole because it's like imaginary. It's just not even there. So he fell into the hole and he went to imaginary land, which had sludge made of poop. Okay, let's move on. The decreasing intervals. So this decreasing interval has the numbers around it. What are the numbers for this decreasing interval? Negative infinity to -4. Negative infinity, that's nice. That always gets a parenthesis. -4. That was down here. When he's down here, is he actively walking downhill? No, he's kind of in between. He's right in between downhill and uphill. That's kind of a neutral space. So we're going to do a parenthesis there. Okay, the other decreasing answer is over here. And what were the two numbers on either side of this decreasing answer? -3 to infinity. -3 infinity. We know the infinity gets a parenthesis. What about the -3? When he started right here, was he actively walking downhill as soon as he got set down right there? Yeah, that's actively walking downhill. Now, so you can put a bracket there. If you always want to use parentheses for increasing and decreasing, you will get marked correct every time. This is the one situation where if you choose that you don't want to mess with brackets, you don't have to. This is like the one thing in math where they'll say like, if you want to be a little bit off, we're okay with it. Right? So bracket is technically okay because he would be walking right here downhill. This would be included. But if you want to put a parenthesis there, nobody's going to be upset about it. Now, whenever we have two answers for increasing intervals or decreasing intervals, or if we have two answers for domain or two answers for range, we put a U in between them. It means union, and it means that for you to be accurate, you have to put both answers. If you put one of the answers, you're wrong. You have to put both answers at the same time to be considered accurate. It's not one or the other, it's both at the same time. All right. Max or min, so we're looking to see in the picture if there's a mountaintop or a valley in the picture. Do you see any mountaintops or valleys? I don't see a mountaintop, but I do see a valley. Anybody see the little valley in there? Where's the little valley at? -4, and what's the y coordinate is 0. So for max, I'm going to put none. For minimum, I'm going to say -4, 0. Okay, x-intercept, y-intercept. Any x-intercepts or y-intercepts in this picture? The y-intercept is 0, -3. Okay, we have a y-intercept at 0, -3. Okay, do we have an x-intercept? We do. -4, 0. We actually have another one. -3, 0. Okay. So 3 intercepts, y-intercept at 0, -3, x-intercept at -4, 0, x-intercept at -3, 0. Okay. Is the graph continuous? Can I trace it with my finger without picking up my finger? So I'm going to start on the left. I'm going to start tracing, pick up my finger, continue tracing. So is this graph continuous? No. In fact, with piecewise functions, the graph is often, not always, it is often not continuous. It is possible for them to be continuous, but it is not common. You're going to say no for most of these. Not always, but often you're going to say no. All right, end behavior, we have to describe our arrows. So I'm going to say as x goes to negative infinity, that's me talking about my left arrow. As x goes to positive infinity, that's me talking about my right arrow. What is the left arrow doing? It goes up. So how do I write that the left arrow goes up? Y goes to positive, okay. Left arrow goes up. X to negative, Y to positive. Left arrow goes up. All right, now I want to say that the right arrow goes down. Y goes to negative. So X goes to positive, Y goes to negative. Left arrow up, right arrow down. So what I've done for the practice assignment today is I've looked at the different pictures of the graphs, and then I'm having you practice a couple of these, and I'm making sure that I'm not asking you to do any really difficult characteristics for a graph where that characteristic would be hard to find. I'm asking you to do kind of basic ones. If you did not take your notes last night, go ahead and go take your notes for the first example now. And then for the rest of you, I'm going to hand out the assignment, and I will come around and check your notes while you guys work on the assignment. That is all we're doing for the rest of class. The other thing is we do have a quiz on Monday, so I'm going to hand out the quiz review. There is no video because over the weekend you're going to be finishing up the assignment from today and working on the quiz review to prepare for Monday's quiz. Whew. Okay.